Welcome to another edition of RCE. I am Brock Palen. You can find the podcast online at rce-cast.com. We're also in the iTunes feed, but there's an RSS feed, and you can find all the old shows there also. I have again Jeff Squyres from Cisco Systems and one of the authors of OpenMPI. Jeff, thanks again for your time.
Hey Brock, how's it going?
Good.
Yeah, so again, we're doing another December recording show here in the doldrums for the HPC world, since it's after supercomputing and before the holidays. So getting another one in, squeezing it in so we can get in by the end of the year.
Yeah, and so all of our usual contact information, you can follow me on Twitter at Brock Palen, and you can find those all linked off of the RCE webpage, as well as my new blog and Jeff's blog, which is actually kind of what got today's topic started.
Yes, it is. So I actually saw an article pointed to by one of the IBM Twitter feeds, Soft Talk blog, an article comparing, well, it wasn't really so much comparing, it was talking about MCAPI, M-C-A-P-I, the Multicore Association communication, I got that all wrong, but we'll get it right in a minute, and MPI. And so, of course, that tweaked my interest there, and I went and read it. And it was a very interesting article. Had slightly different takes on things that I did, and so I actually wrote a response to it, and there was some good discussion that came out of that. And I said, you know what, why don't I just contact these guys? We should talk, because there's some interesting possibilities here between the MCAPI and MPI. And so we said, actually, why don't we even follow that up with a podcast? So here we are. We got two Multicore guys on Skype here with us. So, Sven, I wonder if you could give yourself an introduction.
Sure. Thank you. I'm Sven Brehmer. I'm the president and CEO of PolyCore Software, and we provide multi-core solutions. And I'm also a founding member and of the Multicore Association, as well as the chairman of the MCAPI working group.
Hi, I'm Ted. I'm vice president of sales at PolyCore Software, and I run the sales and business development for PolyCore. And I've been with Sven many, many years at different companies. So we are interested in talking to you about MCAPI and MPI. And what would you like us to say here?
Well, actually, first, what exactly is the Multicore Association, and what is PolyCore's involvement with that?
Sure, I can take that. So the Multicore Association is an industry group that was created to enable the multicore ecosystem. So I think it started in 2005. Marcus Levy and I invited people to a meeting to talk about multicore, and the turnout was way beyond our expectations. And that's how it started. And then we discussed what can we do to actually help the multicore community, and we decided to focus on standards and guidelines. And that's about it.
So who all is involved in the MCA, the Multicore Association? What are your members like?
So it's actually a broad group, or it spans across the industry. So we have semiconductor vendors, and we have software vendors, we have EDA vendors, and we also have some of what I would call the consumers, not being the consumers like you and I, but companies that would actually be the beneficiaries of using the standards. So and then I think we have about 7 universities. So it spans the industry and it spans academia.
So you mentioned that one of your output products is standards. What kind of standards do you make? Software standards or hardware standards or what?
It's primarily software. But I think it touches on the hardware in multiple places. And the first one that we defined was MCAPI, which stands for Multicore Communications API. And it's now out in its second version. And we also defined something called MRAPI, which stands for Multicore Resource Management API. And we are currently working on MCAPI, which stands for Multicore Task Management API. And then there is also a working group working on virtualization, another one working on tools infrastructure, and we also have one working on a Multicore best practices programming guide. And if you look at the MCAPI, MRAPI, and MTAPI, they are basically the foundation standards of the Multicore Association. And you can use them individually or you can use them in combination. And if you use them in combination, some of the concepts are common between them, so you can get some benefits that way, but they can also be used separately.
So we actually want to discuss MCAPI and its components individually as a technology. What is it and what does it aim to accomplish?
All right. So it's, again, a Multicore Communications API, and it's meant to be allow lightweight implementations, primarily focused on embedded systems. And if we look at the API itself, it has a number of functional groups. It deals with node and endpoint management, and a node is defined as a thread of execution, which can take multiple forms. So it can. The intent is that an implementation can run in a full-fledged system with a process model, or down to a bare metal system that doesn't have an operating system. And there are also three types of communication functional groups. So we have connectionless messages, we have connected packet channels, and scalar channels. And for messages and packet channels, they come in blocking and non-blocking versions, and we also have functions to deal with non-blocking operations. And it's also important is that the standard was defined to be agnostic to the number of cores, type of cores, the type of interconnects, and the type of operating systems, or as I said, no operating system. So it should be able to implement it in a very broad range of systems.
So then does it require some sort of hardware support? Like you said, it focused towards embedded systems. If I was using this between units of a couple of FPGAs or something, what would be the requirement to make this work on it?
Yes, the standard does not imply any specific implementation, but certainly implementations need to deal with the hardware. And I can just exemplify from we have something called PolyPlatform, which is a programming platform for multicore, and we have support in PolyPlatform on the runtime side. You have to deal with, of course, if you have different operating systems, how do you actually manage the communication when you have different operating environments? And the same when you look at the interconnect. So of course many systems have shared memory, and in that case you have to deal with shared memory and find the most optimal way to communicate through that medium. Or if you have something like rapid I/O where you have to move data across a wire, you have to deal with that. So that it is left to the implementations of MCAPI, and we did not specify in the standard how to deal with that.
So that's interesting. So you deal, by the name, one would assume Multicore is within a single, shall we say, server, but you said across the wire as well. Does the MCAPI API also allow for communication, say, outside of a server across even something like Ethernet?